Hello everyone. On this video we will be looking at the intermediate value theorem. Okay, so to kind of give you an idea of what the intermediate value theorem is, let's look at this particular example before I give you the general idea. Okay, so let's say you have a graph here. Let's say that this value of y is 15. Let's say that this value right up here, we'll say that this is 4. Okay, so we'll say this value here for x is 1, and this value here is 5. Okay, so we see here between 1 and 5, our interval of 1 and 5, let's say there's some value that we will call c. Okay, so what the intermediate value theorem does is that it says that between these two values on our x-axis, between 1 and 5, there's some c. Okay, and that value c, there exists at least one c where you have k is equal to any number between 4 and 15. So we'll say k is equal to 10. Okay, so since k is between 4 and 15, there is at least one c value that will give you that k. Okay, there is some x value between 1 and 5 that will give you any f of c value between 4 and 15. Okay, now the actual definition pretty much says that, but this is kind of the simplified version of it. So for your intermediate value theorem, or you'll see IVT for like a lot of the examples, states that if f of x is continuous, on the closed interval AB, and k is any number between f of A and f of B, then there is at least one number c in that interval AB, such that, move that up a little bit, that function at the point C is equal to k. Okay, so comparing the two, remember this is our f of x, it's continuous between our A and B interval on the x-axis, and k is a number between f of A and f of B. Okay, so then there's at least one number c that is equal to that k value between there. Okay, so if we kind of wrote up a general graph, so let me have the general graph. Okay, so move this up a little bit more. Okay, so we have our y-axis and our x-axis. Okay, so let's say this is our graph here. It's a closed graph. And this is our interval between A and B. So that means this would be our f of A. And this would be our f of B. Okay, so if we pick a k value anywhere between there, we pick here, we can pick down here, it doesn't matter. Pick a k value, and I'll just pick this k value here. Then that means there exists at least one c value. So this is your k value. I'm going to go ahead and just draw a line through that value. Then there is at least one. Okay, you see in our graph that I had up top, it was just one k value. But depending on what the graph is, there can be more than one. So you have here, you have 1, 2, 3. Okay, so you have 3 values. Okay, so here it could be this c value, we'll call that c number 1. This c value, we'll call that c number 2. Or this c value, we'll call that c number 3. Okay, so just because it says at least one doesn't mean there's only one. It could be more, depending on the graph. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and start on a couple of examples. Okay, so let's say, for example, what if you want to use the intermediate value theorem to show that the polynomial function sorry about that noise outside. So you have f of x is equal to x to the third plus 2x minus 1 has a 0 in the interval 0, 1. Okay, so it's not asking you to find where f of x is equal to 0. They're just showing, they just want you to show that it exists. Okay, using the intermediate value theorem. So how will we do that? First, we have to show that it's continuous. And we can see here between 0 and 1, if you plug in any value between 0 and 1 into that function, it'll exist. Okay, there's no denominator of 0 or no negative square roots. It's continuous throughout the whole thing. So f of x equals x to the third plus 2x minus 1 is continuous between 0 and 1. Alright, every value in between there works. Okay, so now we find our endpoint values. So between 0 and 1, we find our f of 0, is 0 to the third plus 2 times 0 minus 1, which is negative 1. So that means f of 0 equals negative 1. Now we find f of 1, which is 1 to the third plus 2 times 1 minus 1, which is just 2. So we know that f of 1 is equal to 2. Okay, so we know that since f of 0 equals negative 1 and f of 1 equals 2, remember this is negative and this is positive. That means if you're on the y-axis and you're negative, at some point you have to cross the x-axis, which is y equals 0, or f of x equals 0. That means at some point there is a f of c equals 0. Sorry about that. Okay, so just to kind of clear it up, that's kind of your answer here. You just proved it, that using that the 0 exists. Okay, so just to kind of show you visually what we mean. Okay, so let's say f of 0 equals negative 1. Okay, when x equals 0, f of 0 is negative 1. Here, when x is equal to 1, f of 1 equals 2. Okay, so if it's continuous, which we already know that this is continuous, at some point it's going to have to cross the x-axis. Okay, so you have your x-axis, which is f of c equals 0. Okay, we don't need to find that value, but we know that to go from here to here, at some point y has to equal 0, or f of x has to equal 0. All right. Oops, sorry about that. I don't know why I didn't bring it up a little further. Okay, so once again, just to go from here, just because the screen was kind of cut off, you have f of 0 is negative 1, f of 1 equals 2. You get from here to here, you have to cross y equals 0. All right. So if you are still writing, feel free to press pause. But on the next example, we're actually going to figure out how to find that C value. Okay. Okay, so let's say, for example, we want to verify that the intermediate value theorem applies to f of x equals x squared plus x minus 1 for the interval 0 to 5 and find the value of c where f of c is equal to 11. Okay, so not only do we verify that the intermediate value theorem can be applied here, you have to find that value. All right. So we know that f of x is equal to x squared plus x minus 1. Okay, and we know it's continuous between 0 and 5 because any number you plug in between 0 and 5, whether it's 1, 1.5, fractions, decimal, doesn't matter. You plug in any number between 0 and 5, that value will exist. It will not be, there are no undefined values. So we know it is continuous on that interval. All right. So again, we find the endpoint values. So we know that f of 0 adds 0 plus 0 minus 1, so it's negative 1. And we know that f of 5, we have 25, plus 5 is 30, minus 1 is 29, so it's 29. Okay, so that means these are basically your y values. So you have f of 0 and f of 5. So we have f of 0, which is less than f of 5. And we want to find an f of c right between it. Or, you want to just rewrite it. You have negative 1, which is your f of 0, is less than 11, which is your f of c, which is less than 29. Okay, now since 11 is between negative 1 and 29, we know we can apply the intermediate value theorem. So the intermediate value theorem applies. Okay, so that's the first part of the problem. We verified that it applied. Okay, now if we had our f of c and it wasn't between those two, then we wouldn't be able to use it. Or at some point it was not continuous between those two, then you wouldn't be able to use it. Okay, so now we want to find what c value is actually equal to that. Okay, so to find f of c equals 11, we just have to remember that f of c, remember f of x is x squared plus x minus 1, so f of c is c squared plus c minus 1. So to find where f of c is equal to 11, we just find where c squared plus c minus 1 is equal to 11. Right? So all we have to do is set it to 0 by subtracting 11 from both sides. So we have c squared plus c minus 12 equals 0. Okay? So if we go ahead and factor this, bring that up some, that will be c plus 4 times c minus 3 equals 0, which means that c plus 4 equals 0 or c minus 3 can equal 0. Alright, so if we go ahead and solve those two equations, that means c can equal negative 4 or c can equal 3. Okay, so it looks like we're done, but you still have one more thing you have to look out for. Okay, so if you remember, the interval is from 0 to 5. So we can't use this negative 4 because negative 4 is not between 0 and 5. So we can't use that. C equals negative 4 is not in the interval 0 to 5. Okay, so we can't use that one. Now 3 is between 0 and 5. So that's perfectly okay to use. Only valid C value. Okay, so we can see just from that our f of 3 is equal to 11, which is your answer. All right. Okay, so point out one other little thing, and that'll be it. Just a quick little side note. Let's say you have your x and your y axis. Let's say you have your interval between a and b. And let's say you have your f of a, and this is your f of b. And in between your interval a and b, you have some value c. Okay, so going between your a and b, oh, your a and b value, that didn't need to be so long since your f of b is down here. I'll move my dotted line there. There we go. Okay, so let's say that that's your a f of a. And let's say from there you have a piecewise function where if you approach it from your c from the left, it's not equal to c, or f of c. But let's say also that if you approach your c value from the right, it is equal to, let me bring that back down a little bit. So if we bring that back down, okay, so you have your f of b and your f of a, but let's say if you pick some value f of c equals k, right here. Now if you notice, it's right in between. Okay, so we see here, that's why it has to be continuous. F of x is not continuous between the interval a, b. So no c value where f of c is equal to k. All right, so just in case you were wondering, why does it have to be continuous? This is why it would have to be continuous. Okay, because if it's not continuous between a and b, then that means that if we pick a k value in between there, the intermediate value theorem will not work. All right, so I just wanted to clarify that before logging off. Okay, so hopefully this made sense, and I will see you on the next video.